Question number 106. Assertion is aromatic amines are weaker base than ammonia. So first of all, I'll just draw here the structure of aromatic amine. Aniline I've drawn here. Lone pair it has, and this lone pair can be donated. But we're just going to compare it with ammonia. And the statement says aromatic amines are weaker base than ammonia. It means ammonia can easily lose its lone pair, it can easily donate proton. That's why it's a good base as compared to aniline or the aromatic amine. Basically, in case of aniline or aromatic amine, this lone pair get involved in resonance. How? Because it get delocalized over here in this way, here. So that can be represented as, here is the formation of a double bond in this way, NH2, positive charge here, and the negative charge here, this way. Further, it get involved in resonance, and what will happen here? It gets changed into this form. So you can easily understand that why it happens. It means it is not easily able to lose its lone pair, and that's why it is weaker base than ammonia. This continues in this way, and finally the lone pair comes here. It means lone pair get involved in delocalization in resonance basically, and that's why it cannot be lost. While in case of ammonia, it can easily lose its electron pair, and that's why it is a stronger base. Definitely assertion is correct. Let's check the reason. And reason states in aromatic amines, lone pair of electron on nitrogen is delocalized in the ring. That I have already shown you here. It means reason is correct. It is correctly explaining the assertion also. That's why what you will do, we'll just mark here option 1 as the correct option. After that, question number 107. Assertion is rate of SN2 reaction, nucleophilic substitution reaction, which is bimolecular, is faster for CH3Cl than CH3CH2Cl. Basically, if I talk about SN2 reaction, what is the pathway? In this case, the nucleophile attacks over the compound or the substrate from the opposite direction, and if there is more steric hindrance, this attack would be difficult. So if I talk about CH3Cl, carbon atom is here and 3 hydrogen atoms are attached to it. While in case of this, there are 2 hydrogen atoms and 1 methyl group is attached. It means comparatively more steric hindrance is here. That's why in this case rate would be comparatively slower. Let's check the reason also. Reason states in transition state of SN2 reaction, carbon atom is bonded to 5 atoms. First of all, let's check what will happen. Carbon atom is joined with, here this bond is getting broken, and here is the formation of the new bond between the nucleophile and the carbon. This is the transition state. I'll just show you in this way. So in this case, transition state is there in which carbon atom is bonded to 5 atoms also. This is correct statement. But is it correctly explaining the assertion? No, it is not explaining, because explanation for the assertion is the steric hindrance. And that's why in this case I'll choose option 2 as the correct option, because both of assertion and reason are correct, but reason is not correctly explaining the assertion. After that, question number 108. Assertion is the boiling point of alcohol increases with increase in number of carbon atom. This is a correct statement, because as the number of carbon atom increases, van der Waals forces of attraction also increases, and that increases the boiling point. This is the correct statement. Further, reason is extent of hydrogen bonding increases with increase in number of carbon atom. This is an incorrect statement, because extent of hydrogen bonding increases with increase in number of hydrogen atom directly attached with some electronegative atom like oxygen, nitrogen or fluorine. As the number of carbon atom increases, extent of hydrogen bonding decreases. So this statement is the wrong statement. In this case, assertion is correct statement, reason is wrong. So which option you need to choose? Option 3. After that, question number 109. Here is a compound that's an ether, CH3 whole thrice, C, OCH3. On treatment with HI forms methanol, and CH3 whole thrice Ci. It means tertiary iodide it is forming. Reason is departure of CH3OH from this oxonium ion generates very stable carbocation. It means in this case we need to just have a look on the mechanism of the reaction of this ether with Hi. Let's check what will happen. So we have this carbon, 3 methyl groups are attached in this way, further oxygen, and here is CH3. What will happen in the first step? H plus ion is attacking over here. Ether has the lone pair, oxygen atom has the 2 lone pair this way. So there would be the formation of oxonium ion, you know that. Here H and here CH3. This is the positive charge on this oxygen. Highly unstable it is. And what will happen? In this case there is the departure of CH3OH from it. That leads to the formation of a stable carbocation, that is a tertiary carbocation, you can clearly see. This would be formed. Along with that, CH3OH is formed. It means in the reason it is mentioned, departure of CH3OH, that is there in this step. CH3OH is removed from it and it is removed from this oxonium ion that's given here. It means this reason is correct. Now further what will happen? Iodide ion is attacking over here, and if it attacks, there is the formation of a tertiary iodide in this way. Now on the basis of this we can easily check whether the products are these or not. CH3OH is formed and this is also formed. That's why both assertion and reason are correct. Reason is correctly explaining the assertion also. That's why I'll choose option 1 as my correct answer. After this, question number 110. Assertion is aldehyde having at least one alpha hydrogen in the presence of dilute alkali form aldol. Yes, it's a correct statement. Let me take here an aldehyde with alpha hydrogen. Now, if it dimerizes and if it reacts with dilute alkali NaOH, suppose I'm taking, then it forms an aldol, that is CH3 CH OH CH2 CHO. This would be formed. This is aldol. Now, this is correct. Now, alpha hydrogen atoms of carbonyl compound is acidic in nature. Yes, in this case, alpha hydrogen atom is acidic in nature. That's why it shifted to this oxygen to give you aldol. That's why this reason is also correct. And that's why I'll choose option 1 as my correct answer, because reason is correctly explaining assertion also. After that,